Hello everyone, welcome to our presentation today. We are happy to introduce you to our new work, Enhancing Creativity in Virtuality, How Annotations in Creative Support to Innovate Design Ideation in Virtual Reality. Virtual reality is transforming design collaboration with immersive 3D space for teamwork. Annotations, virtual marks, text, and audio are essential for design communication. However, current VR tools focus on real-time interaction, navigating asynchronous workflows. Designers constantly remove headsets to check references or import files, breaking immersions and disturbing creative flow. By noticing these gaps, here we raise three research questions. First, what are the prevailing ideation processes, and how do these processes differ between traditional and virtual environments? And also, in what ways do shifts in designers' annotation habits and strategies affect the ideation process and overall design experience? And also, how do different types of annotations influence designers' creativity and experience? And if there is certain types of annotation outperform others? To answer those research questions, we conducted 3 phase experiments with 53 participants. In phase 1, we conducted an exploratory study with 7 design professionals, including product, brand, and architectural designers. Through 30 to 60 minutes interview, we examined how they apply collaborative ideation tools, their annotation method, current challenge, and their perceptions of VR for design collaboration. In phase 2, we conducted an empirical study with 28 participants to compare traditional and VR environment. We used mirror as baseline, and one group used OpenBrush, while the other used ShapesXR. We analyzed cognitive workload using NASA-TLX and gathered qualitative insights through semi-structured interviews. In phase 1, we identified the key activities in design process as sketching, searching, and presenting. And we also identified the crucial annotation method in ideation process as visual, textual, audio, and referential. Our phase 1 reviews 3 key challenges in current collaboration processes: limited support for reference files, constant multi-tool switching, and disorganized communications. While designers see VR's potential for enhancing the spatial awareness and creativity, they also raise concern about steep learning curves and inconsistent interface across applications. Our NASA-TLX results shows that there are still gaps between virtual collaboration and traditional collaboration, and OpenBrush outperforms ShapesXR in some aspects. The semi-structured interview confirms our phase 1 findings, but the common annotation methods are lack sufficient support in VR. While designers also value the large-scale visualizations and creativity simulations in VR, but the communication barriers and immersive interruptions, especially the absence of seamless reference import, are continuing to disturb creative flow. Based on the findings from phase 1 and phase 2, we now propose our prototype, AsyncCreativity, designed to address users' key design implications. The prototype is built on top of OpenBrush, selects for its open-source architecture and superior ease of use. We developed 4 add-on functions to enhance the VR ideation experience. Our research shows that switching between VR and reality to import files disturbs creative flow. To solve this, we developed a screen streaming widget that lets users to access local files and browse the web without removing their headset. With the drag and drop and capture features, users can seamlessly bring images and references directly into VRC. This forms our referential annotation function, inspired by the resource collection in 2D design. As generative AI becomes integral to design, we developed an AI-assisted tool that generates images from text prompts or existing images. Users can input requests via voice commands to minimize physical strain. Images are proposed on a remote server and delivered directly into the VRC. No need to remove the headset. Handwriting and typing in VR are challenging for capturing semantic information. To address this, we implemented an audio annotation feature. Users simply press a button to record, encoding their messages into an audio clip. Once confirmed, the audio attaches to a visual icon in the scene and can be played back anytime and can be placed in anywhere in the space, enabling quick, low-effort communication. This is our audio annotation function. To support asynchronous collaboration, we built a shared storage system using Firebase. Every annotation and design outcome is transmitted and stored in real time. Each project generates a unique ID based on timestamps and username, ensuring a reliable version control. Users can easily retrieve any past versions of their projects by selecting a timestamp. Beyond our 4 add-on functions, we also returned OpenBrush native features, including freehand sketching and model importing. To support diverse ideation needs, we preload a basic library of models locally, allowing users to quickly access and place reference objects in their VR scenes without breaking immersion. In Phase 3, we deployed AsyncCreativity with 18 participants to evaluate its annotation features. They completed sketching, searching, and presenting tasks in an interior design scenario. We collected system usability scale scores, function-specific feedback, and qualitative insights through observations and interviews. Our prototype achieved a system usability scale of a score of 75.8, outperforming 73 of the system in HKUST database. Among our add-on functions, audio annotation received the highest usefulness and ease of use score. However, while the screen streaming widget was valued for its seamless referencing, participants also report this onboarding challenge, indicating there is a room for further interaction design improvements. In total, we collected 82 annotations, and the results shows that multimodal annotations were most common, 43 binomial and 10 trimodal versus 29 unimodal. Audios were the most frequently used modality, with 57 instances, often paired with sketching. And visual annotations has 38 users, and referential annotations has 16. Significant co-occurrence relationships were found across annotation categories. We analyzed 77 annotations across 5 objectives: add, remove, replace, modify, and move. Quantitatively analyzed reveals the significance relationship between the annotation method and the objectives. Sketch, model import, and AI-assisted images showed strong significance among different annotation objectives. Qualitatively, participants found writing and sketching intuitive for conveying movement paths and spatial areas. Model import raised concerns about creating the universal libraries. Screen streaming widget was valued for its accuracy, while AI generations requires precise prompting. Audio annotations emerged as the most favorite feature, offering clarity, ease of use, and enabling self-exposure during the asynchronous collaboration. To answer the research questions, our research identified 3 core ideation activities: sketching, searching, and presenting. Current challenges including the communication efficiency and constant multi-platform switching. We are introduced additional disadvantages like limited interactions, difficulty accessing external references, and low precision compared to traditional computers. Our key design implications are audio annotations with spatial information reduce physical strain while enabling semantic interpretations and effective communications. Additionally, seamless access to the external multimedia materials is essential for maintaining creative flow in virtual environment. To answer our second research question, VR offers intuitive, immersive experiences, but comes with learning costs and inconsistent design habits, what we call the visual isolation. Annotation strategies are also shifting. Designers prefer multimodal approaches, with audio proved to be highly effective. However, the information overload remains a concern, highlighting the needs for better annotation strategy design. Our findings also shows that designers lack annotation methods based on their objectives. Looking ahead, we envision a new paradigm, annotating the annotations, where audio serves as a meta-annotations, providing context and clarifications around other annotation types to enhance the synchronous communication. Our research carries 3 key implications. First, for VR research, we must understand how multimodal interaction designs impacts cognitive load and creative thinking. For CST development, tools should prioritize seamless transition between traditional and VR environment, with quick access to external resources. And finally, for the VR ideation, we need to cultivate adaptive mindsets and develop educational programs that fully leverage VR's unique advantages in design. Our study identified key ideation activities and annotation methods through stakeholder insights. We found multimodal annotations boost engagement, with audio serving to interpret other types. Limitations including unidirectional output and prompt precision issues. Future works will explore LLM integration, synchronized collaboration, and generative AI for 3D models. That's all for my presentation today, and we are welcome for all kinds of questions.